Hello everyone, welcome to In 5 Minutes. In this video, we are going to see the next problem on gamma function type 1. So the basic representation of gamma is nothing but gamma of n integration of 0 to infinity e raised to minus x raised to n minus 1 dx. So we have to represent the given problem in this equation so that we can apply the property of gamma. So this is our question. In this we have to show that this term is equivalent to this term. So let's consider this integration. We have integration of 0 to infinity a raised to minus 4x square dx. So this integration seems to be very difficult integration, but we can solve this integration by using a gamma function. So in gamma function we need something e raised to minus x, and we do not have e raised to term here. So what we are going to do, we can represent this term as e raised to something, as we know that a is nothing but e raised to log of a. Similarly, a raised to minus 4x square will be nothing but e raised to log of a raised to minus 4x square. And again we are going to apply the property of log. We know that log of x cube is nothing but 3 log of x. So we can take this minus 4x square in front of the log, so we get e raised to minus 4x square log of a. So this term can be represented as this term. So we get I equal to integration of 0 to infinity. This term is represented as e raised to minus 4x square log a into dx. Again, if you see these two equation, we got e raised to something, but we want e raised to x raised to 1. So we will now replace this term by some other variable. So we put 4x square log a equal to t, then x square will be t upon 4 log a, then x will be root of t, root of 4 is 2, and root of log a. After this we take the derivative of this term because we want the term of dx. So 1 upon 2 root log a is constant, so 2 root log a will remain as it is, and derivative of t raised to half, that is root 2, is nothing but t raised to minus half upon 2. So this 2 and this 2 will become 4, and in the numerator we have t raised to minus half into dt. So this is our dx. Now we are putting this term equal to some other variable, so limits of integration will also change. So here we write initial variable, here we write final variable. Initial variable is from 0 to infinity. When we put x equal to 0 in this equation, we get t also equal to 0. When we put x equal to infinity, we get t also infinity. So now we are going to substitute all these terms. So we get I equal to integration of 0 to infinity e raised to minus 4x square log a is nothing but t into dx. What is dx? Dx is this term, that is t raised to minus half into dt upon 4 root of log a. So consider this equation now. So we have this equation, 4 root of log a is constant, so we can take the constant out of the integration. So we get integration of 0 to infinity e raised to minus t raised to minus half dt. Now if we compare this equation with this equation, both the equations are same. Here we have x, here we have t. So what is our n minus 1? N minus 1 is nothing but power of t, that is minus half. So n will be minus half plus 1, and n is nothing but half. So this term is nothing but gamma of n. In our case n is half, so it is gamma of half, and gamma of half is root pi. So this whole term will be replaced by root pi. So our I is nothing but root pi upon 4 root of log a. If you see our question, this term is equivalent to this term. So right hand side is equal to left hand side, hence proved. So this is how we solve the problem on gamma function. More such types we will see in our next video, so stay tuned for our future lectures.